Dear 10th standard students, your new chapter is Numbers and Sequence. Euclidic division lemma. Euclid, one of the most important mathematicians, wrote an important book named Elements in 13 volumes. The first 6 volumes were devoted to geometry, and for this reason Euclid is called the father of geometry. But in the next few volumes he made fundamental contribution to understand the properties of numbers. One among them is the Euclid division lemma. This is simplified version of a long division process that you were performing for division of numbers in earlier classes. Lemma is an auxiliary result used by proving an important theorem. It is usually considered as a mini theorem. Theorem number 1, Euclidean division lemma. Let A and B, if A is greater than B, be any two positive integers, then that exists unique integer Q and R such that A is equal to PQ plus R is greater than or equal to 0, less than B. That is, a number A and B, both are positive integers. A is divided by B. A is the dividend, B is the divisor. The quotient, say as Q, remainder is R. So, the dividend is equal to divisor into quotient plus remainder. The remainder is always less than the divisor or equal to 0. The remainder is always less than the divisor. If R is equal to 0, then A, that is dividend, is equal to B into Q, divisor into quotient. So, B divides A. Conversely, if B divides A, then A is equal to PQ. Example 2.1. We have 34 cakes. Each box can hold 5 cakes only. How many boxes we need to pack and how many cakes are unpacked? We have 34 number of cakes. The cake to be parceled in a box. Each box is only contain 5 cakes. To find number of boxes needed and also number of cakes unpacked, 34 is the dividend, 5 is the divisor. 34 divided by 5, we get the quotient 6. Then the remainder is 4. 5 into 6, 30. 30 plus 4, 34. Total number of cakes as A dividend is equal to number of cakes in each box, 5, that is divisor, says B. Number of boxes, 6, that is quotient Q, plus number of cakes left over, 4, that is remainder R. A is the dividend, that is 34. B is the divisor, that is 5. Q is the quotient, that is 6. R is the remainder, that is 4. A is equal to P into Q plus R, that is 34 is equal to 5 into 6 plus 4. The above lemma is nothing but a restatement of the long division process. The integers Q and R called quotient and remainder respectively. When a positive integer is divided by 2, the remainder is either 0 or 1. So, any positive integer will of the form 2k, 2k plus 1 for some integer k. The positive integer is divided by 2, we get the result is remainder is 0 or 1. When 2 is divided A positive even integer is divided by 2, we get the remainder is 0. A positive odd integer is divided by 2, we get the remainder 1. 2k is even positive integer. 2k plus 1 is odd positive integer. Find the quotient and remainder when A is divided by B in the following case. 1. A is equal to minus 12, B is 5. Second one, A is 17, B is minus 3. Third one, A is minus 90, B is minus 4. First one, A is minus 12, B is 5. By Euclid division lemma, A is equal to PQ plus R. A is the dividend, B is the divisor. When is equal to minus A is minus 12. Minus 12 is equal to 5 into minus 3. 5 into minus 3, 15 plus 3. Minus 15 plus 3, minus 12. R is greater than or equal to 0, lesser than modulus of 5. Therefore, quotient Q is minus 3 and remainder R is 3. Second one, A is 17 and B is minus 3. By Euclid division lemma, A is equal to PQ plus R. Here 17 is equal to minus 3 into, minus 3 is divisor, into minus 5, we get plus 15. Plus 15 plus 2, we get 17. R is greater than or equal to 0, lesser than minus 3. The remainder is always less than the divisor. Therefore, the quotient Q is minus 5 and remainder R is 2. Third one, A is equal to minus 19, B is equal to minus 4. By Euclid division lemma, A is PQ plus R, where R is greater than or equal to 0, lesser than modulus of P. Minus 19 is the dividend. Minus 4 is the divisor. Minus 4 into 5, minus 20. Minus 20 plus 1, minus 19. R is greater than or equal to 0, lesser than modulus of minus 4. R is always less than the divisor. Therefore, quotient Q is 5, remainder R is 1. Example number 2.3. Show that the square of an odd integer is of the form 4q plus 1 for some integer q. The square of an odd integer is in the form of 4q plus 1 to be shown. Here the q is an integer. Let x be any odd integer. Since any odd integer is one more than an even integer. Suppose 5 is an odd integer. 4 is less than 5. 4 plus 1 we get 5. So even integer, sum of the even integer plus 1 we get an odd integer. We have x is equal to 2k. 2k is even integer plus 1. We get 2k plus 1 is odd integer. So x is equal to 2k plus 1. X is an odd integer. For some integer k, x square, squaring on both sides, x is equal to 2k plus 1. 2k plus 1 is squaring on both sides. We get x square is equal to 2k plus 1 the whole square. That is a plus b the whole square. Here 2k is a, 1 is b. 2k square, 4k square plus 2 into 2k plus 1, 4k. 1 square, 1. Here 4 is common and also k is common. Taken out 4k into k plus 1 plus 1. K into k plus 1 is some integer. That say as q. 4q plus 1, where q is equal to k into k plus 1 is some integer. So you write 4q plus 1. We get of an odd integer is in the form of 4k plus 1. We show that. Exercise 2.1 first sum. Find all positive integers when divided by 3 leaves remainder 2. In the sum given, to find all positive integers which when divided by 3 leaves the remainder 2. A positive integer is divided by 3. We get the remainder is 2. To find the all positive integer. That by Euclid division lemma. Division lemma is A is equal to PQ plus R. Here P is the divisor. Divisor is 3. R is the remainder. R is 2. So A is equal to 3Q plus 2. When give the value, when give Q values as 0, 1, 2, 3 and so on, we get the A value. Suppose 0, Q is 0, 3 into 0, 0, 0 plus 2, we get 2, A is 2. Then 1, 3 into 1 plus 2, 3 into 1, 3, 3 plus 2, 5. 2, 2 into 3 into 2, 6, 6 plus 2, 8. 4, 3, 3 into 3, 9 plus 2, 11. 4, 3 into 4, 12, 12 plus 2, 14 and so on. So the value of A is 2, 5, 9, 8, 11, 14 and so on. Exercise 2.1 sum number 2. A man has 532 flower plots. He wants to arrange them in rows such that each row contains 21 flower plots. Find the number of completed rows and how many flower plots are left over. Given number of flower plots 532. All plots to be arranged in rows and each row containing 21 flower plots. Here A is 532 and B is 21. A is the dividend and B is the divisor. By Euclid division lemma, A is equal to PQ plus R. A is 532 is equal to P is 21, 21Q plus R. 532 divided by 21. 2 into 21 we get 42. 53 minus 42. 3 minus 2, 1. 5 minus 4, 1. Stubbed out 2. 112 is divided by 21. 5 times 5 into 21, 105. 112 minus 105 we get 7. Here quotient is 25, remainder is 7. 532 is equal to 21Q plus R. 532 is equal to 21 into 25 plus 7. Therefore, number of completed row is 25. Number of flower plot left out is 7. Here quotient is 25 and remainder is 7.